Let's talk about the kinds of angles that are created when parallel lines are cut by a transversal. First, let's talk about how to label parallel lines on a diagram. To label two lines as being parallel to each other, you put these little triangles pointing in the same direction on the lines. Sometimes instead of triangles, you'll also see them drawn as arrows instead. And the notation, if you're writing that two lines are parallel, is two slashed lines, like what you see here. So this statement right here would be read as line A is parallel to line B. And if you have two parallel lines, like how line A and line B in this diagram are shown to be parallel, cut by a transversal, remember we learned that word in our previous lesson, transversal is the name for a line that intersects two other lines at different points, so T would be our transversal. If you have two parallel lines cut by a transversal, then the corresponding angles are congruent according to the corresponding angles postulate. Remember from our previous lesson that corresponding angles are the angles that occupy the same position out of the four angles that are created by the intersection of two lines. So for example, in this diagram, angle 1 and angle 3 are corresponding because they're both in the top left-hand corner. So therefore, since line A and line B are parallel, we can conclude that angle 1 and angle 3 are congruent. We can say the same thing about angle 5 and angle 7. They're both in the top right, which makes them corresponding angles. And since A is parallel to B, that makes them congruent. And same thing with angle 2 and angle 4, and angle 6 and angle 8. They're corresponding angle pairs as well, and since line A is parallel to line B, they would be congruent. Alternate interior angles are the angles that lie on opposite sides of the transversal. That's what alternate means. And they lie in between the two parallel lines. That's what interior means. So if you have two parallel lines cut by a transversal, then the alternate interior angles are congruent. So in this diagram, we would be able to say that angle 2 is congruent to angle 7, and we would be able to say that angle 3 is congruent to angle 6 because of the alternate interior angles theorem. Similarly, we have the alternate exterior angles theorem, which says that alternate exterior angles are congruent if the lines are parallel. So since line A is parallel to line B, that allows us to assume that alternate exterior angles are congruent. Alternate again means that they're on opposite sides, so angle 1 is on the left, angle 8 is on the right of transversal T. That makes them alternate. And they lie on the outside of the two parallel lines, which makes them exterior. So angle 1 is congruent to angle 8, and angle 4 is congruent to angle 5. And then our last theorem that we're learning today is the consecutive interior angles theorem. And it's a little bit different than the first three because this time we are assuming that they are supplementary angles instead of congruent angles. Remember that consecutive means they're on the same side of the transversal. So angle 2 and angle 3 are both on the left-hand side of the transversal T. That makes them consecutive. And they're interior because they're in between the two parallel lines. But unlike our other theorems that say that we have congruent angles, angle 2 and angle 3 as consecutive interior angles are supplementary to each other. And angle 6 and angle 7 would also be supplementary. So a quick vocab recap. Corresponding angles are congruent, alternate interior angles are congruent, and alternate exterior angles are congruent. Whereas consecutive interior angles are supplementary. Now these first four things are only true if it's parallel lines that are cut by a transversal. If the lines are not parallel, then you don't know any of this is true. And then also a quick vocab recap from the last couple of units. Vertical angles are always congruent and linear pairs are always supplementary regardless of whether lines are parallel or not. So let's do some practicing. We've got a pretty crazy looking diagram here, lots of numbers and lines and everything all over the place. I'm going to give you a pair of angles each time, and we are going to identify which line is the transversal, and what kind of angles they are, whether they're alternate exterior or consecutive interior or corresponding or whatever, and then we'll say if they are congruent or they are supplementary. So let's begin with angle 11 and angle 8. Angle 11 and angle 8 are these two. So which line is the transversal? Well, that's the line that goes in between both of them. There's really 3 lines that make up this part of the diagram that we care about for angle 8 and angle 11. So I'm actually going to erase part of the diagram so we can just focus on the part that we need. Angle 11 is created by the intersection of line B and line N, and angle 8 is created by the intersection of line A and line N. Since both of those angles were created from a line called N, that makes the transversal N. And notice that the other 2 lines in this part of the diagram, line A and line B, are marked as parallel. Angle 8 and angle 11 are alternate interior angles because they are on opposite sides of transversal N and they're in between the 2 parallel lines A and B. So since they're alternate interior angles created from the intersection of 2 parallel lines and a transversal, that makes them congruent. Let's look at another pair of angles. This time let's talk about angle 2 and angle 3. That's these 2. So for these 2 angles, I'm just going to focus on this part of the diagram, and I really don't need that stuff down there. It's just distracting. So looking at these 3 lines that created angle 2 and angle 3, the transversal is the one that created both of them. So the transversal would be A. It's the one that goes in between both of the angles. These angles are consecutive interior angles because they're both on the top side of transversal A, and they're in between the 2 parallel lines. That makes them consecutive interior. And since the lines are parallel, we can assume that those angles would be supplementary. Now let's talk about angle 13 and angle 12. That's these ones. So for these 2 angles, I'm only going to focus on this part of my diagram. I really don't need this stuff up here. So which of these 3 lines is my transversal? Well, that would be line B, because angle 13 was created by the intersection of line M and line B, and angle 12 was created by the intersection of line N and line B. So since both of these angles were created using line B, B is the transversal. B is the one that intersects the 2 parallel lines. Angle 13 and angle 12 are on opposite sides of the transversal. One's below it and the other one's above it. That makes them alternate. And they're on the outside of the 2 parallel lines, M and N, so that makes them exterior. So I can say that angle 13 and angle 12 are alternate exterior angles. And since line M is parallel to line N, I would be able to conclude that those 2 angles are congruent to each other. Alright, I want you to try this last one on your own. Looking at angle 1 and angle 9, figure out which line is the transversal, what kind of pair of angles they are, and whether they are congruent or supplementary. Pause the video and give it a try. Let's see how you did. I'm just going to focus my attention on this part of the diagram, and that shows me that line M is the transversal that passes between these 2 angles. It's the one that intersects the 2 parallel lines. Angle 1 and angle 9 would be called corresponding angles because they occupy the same position out of the 4 angles that were created by the intersection of each line. They're both basically in the top left-hand corner. And since the lines are parallel, I can assume that they are congruent to each other. For our next set of examples, I'm going to give you some information about a pair of angles, and we're going to state whether that can or cannot be assumed as true based on the information that we see in the diagram. For example, let's talk about angle 2 and angle 7. These 2 angles are alternate exterior angles because they're on opposite sides of the transversal and they're outside of the parallel lines. So since I have these 2 lines marked as being parallel, and since angle 2 and angle 7 are an alternate exterior angle pair, is that something that I can conclude is true? Can I say that angle 2 is congruent to angle 7? Yes, I definitely can. That is true by the alternate exterior angles theorem. What about angle 2 and angle 3? That's these 2. What kind of angle pair are they? Well, actually it has nothing to do with this line down here, right? Angle 5, 6, and 7, and 8 don't matter. I'm really just talking about the intersection of these 2 lines, which makes them vertical angles. And since they're vertical angles, they have to be congruent to each other by the vertical angles congruence theorem. What about angle 2 and angle 8? That's these 2. What kind of special pair of angles are they? Well, they're not. We don't actually have something called consecutive exterior for some reason. We could, but we don't define that. But that's what these would be called according to the vocab that we know, because they are on the same side of the transversal, and they're on the outside of the two parallel lines, so that would make them consecutive exterior, and we don't know anything about consecutive exterior, so we cannot assume that those two angles are congruent to each other. If anything, we would be able to say that they are supplementary to each other. What about angle 3 and angle 5? Can I say that they're congruent to each other? Well, what kind of pair of angles are they? They're consecutive interior. They're both on the left-hand side of the transversal, and they're in between the two parallel lines. That makes them consecutive interior angles. But are consecutive interior angles congruent? No. Consecutive interior angles are supplementary to each other, so this statement would be false. And what about angle 3 and angle 6 instead? What kind of pair of angles are they? Well, they would be alternate because they're on opposite sides of the transversal, and interior because they're in between the two parallel lines. So since I have parallel lines and alternate interior angles, yes, I can assume that angle 3 is congruent to angle 6 because of the alternate interior angles theorem. And what about angle 3 and angle 7? Can I say that those two are congruent to each other? Yeah, I definitely can, because they're corresponding angles. Out of the 4 angles created by the intersection of two lines, both of these angles are basically in the bottom left-hand corner. Since they occupy the same position, that makes them corresponding angles. And since these two lines are parallel to each other, that allows me to conclude that angle 3 must be congruent to angle 7 by the corresponding angles postulate. Well, enough about congruence. Let's try supplementary. Can I assume that angle 4 is supplementary to angle 6? Yes. Yes, I can. Angle 4 and angle 6 are consecutive interior angles because they're both on the same side of the transversal and they lie in between the two parallel lines. That makes them consecutive interior. And since the lines are parallel, we can assume that those two angles must be supplementary by the consecutive interior angles theorem. Can I say that angle 4 is supplementary to angle 8? No. No, I cannot. Angle 4 and angle 8 are basically in the bottom right-hand corner out of the 4 angles that were created by the intersection of each pair of lines. So since they occupy the same positions, that makes them corresponding. And what I know about corresponding angles is that they are congruent, not that they're supplementary. So I cannot assume that angle 4 and angle 8 are supplementary. Can I say that angle 4 and angle 3 are supplementary? Well, yeah, but that's from an old school reason, not from this chapter, it's from last chapter. That's the linear pair postulate. Since angle 4 and angle 3 are built from a straight line, the literal definition is that they are adjacent angles whose non-common sides are opposite rays. That makes them a linear pair. And since they're a linear pair, they must be supplementary by the linear pair postulate. We can use the relationships between each of the angle pairs created by parallel lines cut by a transversal to calculate all 8 of the angle measures. If you know one angle, then you know all of them. So we're told that the measure of angle 1 is 112 degrees. What other angles must also measure 112 degrees? Well, what about angle 4? Those are vertical angles, right? And vertical angles have to be congruent to each other. So since angle 1 is 112 degrees, angle 4 must be 112 degrees as well. What other angles must be congruent to angle 1 and angle 4? Well, what about angle 5? Whether you're thinking about it as angle 1 and angle 5 are corresponding, or that angle 4 and angle 5 are alternate interior, either way, since these two lines are parallel, I can say that all 3 of these angles are congruent, which means angle 5 is 112 degrees as well. And there's actually one more angle that also measures 112 degrees, and that would be angle 8. You can either say it's because angle 5 and angle 8 are vertical, you could say it's because angle 4 and angle 8 are corresponding, or you could say it's because angle 1 and angle 8 are alternate exterior. Either way, you'll get to an answer of angle 8 measures 112 degrees. So what about these other 4 angles, angle 2, angle 3, angle 6, and angle 7? How do I figure out their angle measures? Well, let's just talk about angle 2 first. Angle 1 and angle 2 form a linear pair, right? Or you could also say that angle 2 and angle 4 form a linear pair. Either way, you would know that the pink angle and the blue angle are going to add up to 180 degrees. So since the pink angle measures 112, The blue angle must measure 68, because that's what you would add to 112 to get to a total of 180. Well, now that I know that angle 2 is 68 degrees, I can say that angle 3 must also be 68 degrees, because they're vertical angles. And I can say that angle 6 is also 68 degrees, because, well, there's a couple ways, because angle 3 and angle 6 are alternate interior angles, so they must be congruent, or because angle 2 and angle 6 are corresponding angles, so they must be congruent. And last but not least, angle 7 must also be 68 degrees, either because angle 6 and angle 7 are vertical, or because angle 3 and angle 7 are corresponding, or because angle 2 and angle 7 are alternate exterior angles. There's a lot of angle pair relationships that you can use to get to each of these answers. But the cool thing is, as long as you know one angle measure, you can figure out the other 7. And that's the basics of what you need to know about angles created by parallel lines and transversals. In our next lesson, we're going to discuss a little bit more in depth about how we can use these angle pair relationships to solve equations.